This presentation speaks to the MD15128 scope of work. It is the test procedures required in government laboratories in Canada. Fume hood certification is to be done on an annual basis. For existing fume hoods, there must be a tracer gas verification every 5 years. And if this has not been done, it is suggested that a budget be included to do such as soon as possible. It is suggested that these tests can be phased in at 20% of fume hoods for each year over the next 5 years on an ongoing basis. The tracer gas tests are to prove sash movement containment for VAV fume hoods, VAV response and stability tests. For VAV systems, the two tests can be done at the same time. Preliminary procedures. Where access allows, using a smoke pencil, check the integrity of all seals around light and other fixtures. Check that the sash stop is still in place and operate properly. Check that all baffles are in the same positions as in previous tests. Determine whether significant sized laboratory equipment inside the hood is the same as for previous tests. Visually inspect the fan and motor, pulleys and belt. Is the belt at correct tension? There should be approximately 0.5 inches of play. Are fan and motor pulleys in good shape? Are they worn or slipping? Ask the service provider and user if belts and pulleys have been changed since the last set of tests. Inquire as to what the normal sash face working height is. It is usually 300 millimeters or 12 inches, but can be 450 millimeters and 18 inches, and on occasion as much as 600 millimeters, 24 inches. The MD15128 scope of work. Sash face velocity tests. Measure the length of the sash opening. Divide by 10. Using a black magic marker, mark these increments on the bottom or top of the horizontal length of the sash. Mark both sides of the sash face vertical at 6 inch heights. Using a thermal anemometer with articulated probe, measure the velocity in meters per second or feet per minute in the middle of each of the resultant scales. Nowadays, an electronic velocity thermometer is used. There should be a minimum of 15 seconds between each reading. Total the 20 test readings and divide by 20 to determine the average air velocity in meters per second or feet per minute through the sash face opening. The average velocity reading between 0.5 meters per second, 100 feet per minute, between 45 meters per second, 0.55 meters per second should be achieved. Report findings. Depending how the contract stipulates, you may have to go to the exhaust fan and rectify if things are not correct. If this work is not stipulated in the certification contract, it may be an extra. This rectification is usually not included in the contract, as it is not known how many fume hoods have to be adjusted, and this would make it very difficult for the contractor to quote. Proof of annual meter calibration is required for MD15128 work. If between 0.45 meters per second and 0.5 meters per second is achieved, do smoke pencil tests. One should be aware if there are two off-the-scale readings the fume hood baffles should be adjusted and the tests redone. Be aware that these off-scale readings are only an indication of faulty fume hood operation if the fume hood is empty. It must be mentioned that fume hoods are seldom empty when tests are being done, as fume hoods are not used in an empty condition. This will affect the number of off-the-scale readings. Smoke pencil tests. With the sash at the designating working height, 12 inches or 18 inches open, use a smoke pencil test for turbulence in front of hood at center, turbulence in front of hood at corners. Capture the distance from the face of the hood. Reverse flow inside hood along walls. Reverse flow inside hood along floor. Eddies inside the fume hood. Eddies under the sash bar. Note whether acceptable or not. Cross-draft velocity tests for MD151 scope of work. Using a thermal anemometer. Position 18 inches to ensure there is not a draft across the sash face opening exceeding 50% of the average face velocity. The average face velocity reading ideally being 100 feet per minute. Smoke containment. Place a smoke emitter in the center of the fume hood. Energize and observe to ensure proper containment, which means all smoke must be carried to the back of the hood. Ensure that the smoke emitter does not produce more smoke than the fume hood rate of exhaust. If not, smoke will migrate to the front of the fume hood and produce a false fail test. For example, if a 40-inch wide by 18-inch sash open is in use, this is a cross-sectional area of 5 square feet. If there are an average air velocity through the sash openings of 100 feet per minute, the fume hood can exhaust 500 CFM of smoke. If the smoke emitter produces more than 500 CFM of smoke, the excess will migrate to the front of the fume hood. After the smoke emitter is turned off, the smoke should be cleared from the fume hood in 60 seconds or less. Some departments have been known to use theatrical smoke devices to do their own tests. This is wrong, as these devices cannot be set to produce controlled volumes of smoke. Monitor an alarm. When the average sash face velocity is determined, check that the fume hood monitor is indicating the same velocity reading. Calibrate the monitor as required. Lower or raise the sash to cause the sash face velocity to change and note whether the audible alarm sounds. Calibrate the arm as required. Fume hood lading. Attach a certification label to the fume hood, which includes test company, technician, his signature, date, average sash face velocity, sash face open position. Insert information in the fume hood logbooks. Provide a 1-inch white 3-ring binder to logbook for each fume hood. Leave at the fume hood. Include above test result sheets in this logbook. The cover page should include building, laboratory, fume hood. The fume hood master document. Provide 2 suitably sized white 3-ring binders to the contracting authority. Contained in these binders will be a copy of the test sheets for all the fume hoods tested. The cover page should include building and date. Thank you very much for listening.